In the previous video, we understood what generative AI is and why it is so important today. Now, before we go deeper, let's quickly test your understanding. This will make the next concepts much clearer. If you can answer these correctly, you are already ahead of most candidates. So let's begin with a quick quiz. Pause the video and think before answering. First question, what does generative AI mainly do? Is it A, prediction, B, content generation, C, storage, or D, deletion? Pause the video if you need more time to think. The correct answer is option B. Generative AI generates new content using learned patterns. It is not limited to prediction or storage. Next question. What does traditional AI mostly do? Is it A, prediction, B, classification, C, optimization, or D, not sure? Pause the video if you need more time to think. The correct answer is option A. Traditional AI focuses on analyze and predict data patterns. It does not generate new outputs. Great job if you got those right. To understand generative AI better, we need stronger fundamentals. So let's begin with the basics. This video focuses on 3 key concepts: artificial intelligence, machine learning, deep learning. These form the core foundation of generative AI. Let's start with artificial intelligence. AI refers to systems that exhibit human-like intelligence, meaning they can reason and make decisions. More formally, AI enables machines to perform tasks. Tasks that normally require human intelligence, such as reasoning or problem-solving. For example, a system can detect anomalies in transactions or perform medical image diagnosis using patterns. These are typical AI-driven tasks. The core idea is straightforward. We design systems capable of intelligent decision-making, similar to how humans operate. This leads to an important question. How do machines learn from data and patterns? The answer lies in machine learning. Machine learning is a subset of AI, where models learn from training data instead of fixed rules, and improve over time. Instead of writing explicit instructions, we train models. The model learns patterns from data automatically and uses them to make predictions. Learning happens through exposure to examples. The system observes multiple examples and detects patterns, then generalizes to new data. One critical requirement is data. Machine learning depends on large training data sets to achieve reliable accuracy. Computation is equally important. Training requires high computational power, especially with large-scale data. Algorithms drive the learning process. They identify patterns and relationships in data and build predictive models. Machine learning acts as an enabler for AI. It allows systems to learn without explicit programming and improve with experience. Now let's move to deep learning. Deep learning is a subset of machine learning, designed for complex problems. This approach uses layered architectures, commonly referred to as neural networks, to process information. Each layer processes incoming data step by step, passing it through multiple computational layers, refining the output progressively. This layered design is powerful. It enables complex pattern learning across datasets, improving overall accuracy. Deep learning performs well on advanced tasks, especially in text and image generation scenarios, where complexity is high. However, this comes with a cost. Deep learning needs massive computational resources for training and inference,
Recent advancements change this landscape. With GPUs and scalable compute widely available, adoption increased rapidly. So, deep learning can be defined simply. It is machine learning using neural networks with multiple layers of processing. Here's the key idea you should remember. Neural networks are a subset, and they often deliver higher accuracy compared to simpler models, especially when the problem is complex. Now let's connect everything together. We have a clear AI ML DL hierarchy, where each builds on the previous. AI is the broader concept, focused on human-like intelligence in machines across various tasks. Machine learning enables this capability. By learning from data and patterns instead of predefined rules. Deep learning is a specialized subset, using multi-layer neural networks to solve complex problems. With this foundation in place, we can now explore generative AI deeper in the next step. Let's move to the next video, where we dive deeper into generative AI systems. I will see you there.